Alright guys, we're going to look at Pythagorean theorem and special right triangles, your 30, 60, 90, 45, 45, 90 today. Let's start with Pythagorean theorem, which is that a squared plus b squared equals c squared, right? The a squared and b squared are each of the legs, and the c would be the hypotenuse. So for this example here, we have a 6 and a 6. So those are the legs, so I can write this as 6 squared plus 6 squared is equal to x squared. I just go through and solve this now. This gives me 36. This gives me 36. I'm going to combine like terms. I'm going to also flip it. So I'm going to make this x squared is equal to 72, which then requires me to solve this using square root operations, square root both sides. And I have to say, well, is there a perfect square for 72? And the answer to the question is no, so I have to break this down. Square root of 36, square root of 2, square root of 36 is a whole number 6. So my answer, if I look at my two factors, are x equals 6 root 2. For another example over here, just to set it up again, this is the hypotenuse with each one of my legs. I think it's crucial that we see things faster. And what you're going to notice with this one is this guy over here gave us 6 root 2. This one's going to be a Pythagorean triple because if I do 5 squared, which is 25, this is 144, and I get is equal to x squared. Let's flip it like I did before to get 169. I square root both sides. The square root of 169 is 13. So sometimes these answers give me whole numbers, and those are called Pythagorean triples, something that we want to recognize for things like NJSLA tests and the SAT, ACT. So that's Pythagorean theorem. I feel like you're well versed in that at this point. Let's go back over 45, 45, 90, which I have down here. Remember, with 45, 45, 90, we're looking at two legs that are going to be the same. This is an isosceles right triangle. The biggest thing here is that the hypotenuse is going to be root 2 greater than whatever that side length is. So usually what ratio I set up is if it's 45, 45, 90, then I write 1 to 1 to root 2. And remember, as we talked about in class, we multiply to go this way, we divide to go that way. So if I want to set the one on the bottom here, right, I have one of my 45s is an x, one of my 45s is y, and the 6 is my hypotenuse, or that 90. Because remember, we're looking at how it points across from it. So instead of saying 45, 45, 90, I could set this up as x, y, and 6. So if I want to find x, for instance, well, in this example, I'm actually finding both at the same time because they're both congruent. All I have to do is work this way, which remember tells us we are going to be dividing, and we're going to divide by root 2. So I'm going to divide 6 by root 2. I'll do it over here. Remember what we talked about in one of the previous lessons, no racks in the basement, so I got to multiply by root 2 over root 2. It's going to be 6 root 2 over square root of 4, and the square root of 4 is a normal 2. So I have 6 root 2 over 2. And now I can do the division of my whole numbers, which is 3 root 2. Meaning that x is going to be 3 root 2, and y is going to be 3 root 2. So just a friendly reminder, when you're working with 45, 45, 90, excuse my dog's in the background. When you're working with 45, 45, 90, you're going to divide to go backwards and multiply to move forward. You'll see that in the homework. You just got to figure out which one to do in that instance. So the last relationship we're going to look at here is 30, 60, 90. And that one I have set up right here. I have the side that points across from the 30. Remember, that's the one we're always going to want to go after. Actually, it kind of looks like I drew to the 60 there. It goes to the side here. And then we have the 60, which is across, is going to be root 3 scaled and then double. So we said 30, 60, 90. It's going to be 1 to root 3 to 2. And if we work this way, we're going to multiply, and work this way, we're going to divide. All right, we just have to pay attention. Are we multiplying or dividing by 2, or are we multiplying and dividing by root 3? And the biggest idea is to get the 30 first. Right? We want to get 30 because everything expands from 30. So let's do this problem down here. Right now, across from the 30, I have G. Across from what would be 60, I have H. And across from the 90, I have the 6 root 2. So I'm going to set up my 30, 60, 90, and I'm going to write G, H, and 6 root 2. So remember what I said before, let's start with 30. So that means I got to use this 90 and go all the way back to 30. Well, if I'm working backwards, I'm going to be dividing. So I'm going to divide by the relationship here, which is 2. So divide by 2. So let's do it over here. I have 6 root 2 divided by 2, which I can do the division, and I get 3 root 2. So now I know that G, which is this up here, is going to be 3 root 2. And if I look at this, I have 3 root 2, H, and 6 root 2. So now that I have 30, my last move is to use 30 to get 60, which again, we're moving this way, so we're going to be multiplying. We're going to multiply the relationship, which is 60, which is the root 3. So we're going to multiply by root 3. That's this that I'm multiplying by root 3. I'm done with the 6 root 2. I'm working on this now, which is 3 root 2 times root 3. Both of those are prime, so we multiply them together. I can't simplify, and I get 3 root 6. Those are my two answers for G and H. I think the biggest thing here to remember is kind of similar to the last example. Multiply to move to the right, divide to get to the left, and of course, we're working with root 3 and 2. Get that 30 first. If you don't have it, get it, then use it to either get 60 or 90. So get 30 first. Remember to scroll down to the bottom of your worksheet to get the answer key. If you have any questions or concerns, feel free to email us.